Chemical reactions are when substances react to form new chemically different substances. In this video we'll be showing you a few different types of reactions as well as a little bit about chemical equations. We hope you enjoy the video and learn something new. In chemical reactions, the atoms are often rearranged to make new molecules. Unlike physical reactions such as changing state, where the molecules remain the same but their arrangement changes. Some of the things you may observe during chemical reactions are a colour change, forming a new substance like a gas, a temperature change, or perhaps a flame.
Chemical reactions can be represented using either word or symbol equations. Here I have three different chemical reactions with their respective word and symbol equations. The first one is hydrochloric acid reacting with sodium hydroxide to make sodium chloride and water. And here is the symbol equation for that reaction. So what we want is we want the same number of atoms of each element on each side of the chemical equation. So here you'll see we have two hydrogen atoms, one chlorine atom, one sodium atom, and one oxygen atom. So now we need the same on the right hand side. So you'll see we have the two hydrogens, we have one oxygen, one sodium, and one chlorine. So that's perfect, that's already balanced, we don't need to do anything to it. So the second one is hydrogen plus nitrogen to make ammonia. So here we have H2 plus N2 to make NH3. So now instantly you'll notice that we have an issue with the nitrogens, as well as the hydrogens actually, but we can deal with the nitrogens first. So we have two on the left, but only one on the right. So if I add a big 2 in front of the NH3, which is called the balancing number, this will help me balance the nitrogens. But then you'll notice that I actually have 6 hydrogens on the right, but only 2 on the left. But I can solve that by adding a 3 in front of the H2. So what this actually is when the reaction is balanced, is actually 3 molecules of hydrogen gas reacting with 1 molecule of nitrogen gas to make 2 molecules of ammonia. The third one, sodium plus chlorine to make sodium chloride. Na plus Cl2 to make NaCl. So here, very similar, I have an issue with the chlorines, 2 on the left but only 1 on the right. So if I add a 2 here, but now you'll notice that I have an issue with the sodium. So I have 2 NAs here but only 1 Na there. So I need to balance this by putting 2 there. So 2 sodiums which react with 1 molecule of chlorine to make 2 molecules of sodium chloride. So the thing with chemical reactions and equations is that not all substances will be in the same physical state. So chemists represent that by adding state symbols just underneath in brackets. So for example, sodium during this reaction is a solid. So it just has a small s in a bracket. Chlorine exists as a gas. So it's just small bracket and gas. And sodium chloride, the product, is actually a solid again. So this is a solid. Combustion is a very important reaction in the world of chemistry. For it, you need a fuel, oxygen, and heat. We are going to be burning or combusting hexane. This is the equation. So it's hexane plus oxygen makes carbon dioxide and water vapor. And the equation has been balanced with the stoichiometric coefficients. So now I'm going to be burning the hexane. Just put it close. See, and there you can see the hexane is now burning or combusting in this case.
An important type of reaction to know is a displacement reaction. Here I've got potassium iodide and chlorine water. Basically just chlorine dissolved in water. Now, if I mix them together, we should see a colour change. As you can see, we get this kind of orangey brown colour. Now, the chlorine is more reactive than the iodine, so it kind of kicks out or displaces, hence the name, the iodine, forming potassium chloride and iodine, which dissolves in water, and that creates this colour. That's the iodine you're seeing there. Now, all of these are dissolved in water, hence you see here AQ. AQ stands for aqueous, which basically means is something dissolved in water. Like the last reaction, this reaction is also a displacement reaction. On the right, you can see a zinc strip dipped in copper sulfate solution, reacting to create zinc sulfate and copper solid, which is the powder you can see forming on the zinc. On the left, we have copper solid dipped in zinc sulfate solution, which isn't reacting at all. This is because zinc is more reactive than copper, so zinc has displaced the copper on the right, but the copper can't displace the zinc on the left.
Neutralization is also another very important reaction in the world of chemistry. Is when an acid and alkali react together to make a salt and water. Here we'll be reacting hydrochloric acid and sodium hydroxide to make sodium chloride, which is actually table salt, and water. So this is hydrochloric acid with some universal indicator added to it, and this is sodium hydroxide with the universal indicator added. But in reality, they are both colorless solutions. So now, when I react the two together, the product is actually a colorless solution. And when I add the universal indicator, you can see that it's going green, which suggests that a neutral solution has been formed.
All chemical reactions can be classified as either endothermic or exothermic. Endothermic reactions are when more heat is given into the reaction than comes out. Exothermic reactions are when more heat comes out. For example, when you're burning something, flame is produced, there's a lot of heat produced there, so it's exothermic. A good example of an exothermic reaction is potassium in water. During the course of this reaction, you may see some flames. Now, if you remember correctly, this is a very vigorous reaction. This is the equation for the reactions. The potassium and the water react to form potassium hydroxide and hydrogen gas. The flames are predominantly the hydrogen gas burning after it's been released. That takes quite a bit of heat, showing that this is indeed an exothermic reaction. Another good example of an exothermic reaction is the burning of magnesium. Now, this was really magnesium solid burning in oxygen to produce magnesium oxide. Magnesium being the fuel, oxygen being present, and heat being present, making a combustion reaction. Now, obviously there's heat being added, as it's a combustion reaction, by the Bunsen. However, the heat produced is much, much greater. So we should have a very exothermic reaction. There you go. I should have worn sunglasses. As you can see, very, very exothermic reaction because the extreme amount of heat that's produced is much greater than the heat that was added.
So now we'll be dissolving salt. This salt, potassium nitrate, dissolves endothermically. So what I'm going to be doing is adding some potassium nitrate to the beaker of water and seeing how the temperature changes. So the initial temperature of the water is 22.3 degrees Celsius. So just keep that in mind before we start the reaction. So now I'm just going to add a bit of potassium nitrate to the water and I will stir. Add a bit more. Stir. So now, as you can see, the temperature on the thermometer is decreasing. So it's now at 21.5 and it started at 22.3. So now you can see it's continuously decreasing. Now it's at 21.3. So what's actually happening here is that energy is being taken from the surroundings, i.e. the thermometer, to break the bonds inside the potassium nitrate, which is why the temperature reading decreases. So now you can see it's at 21. So now we're going to be doing a thermal decomposition reaction of magnesium nitrate, which is an endothermic reaction. To see that the reaction is happening, we should also be able to see brown NO2 gas, which is a product of the reaction. I'm just going to start gently heating the magnesium nitrate.
Chemical reactions create everything we interact with in life. The food we eat, the water we drink, even our own cells are made with chemical reactions. We hope you guys enjoyed this video and learned something new. And remember to stay sciencey.